This is the Energy Infrastructure and Recommendation for Ann Arbor, Michigan by Preston, Rashkov, and Emily LeBlanc. So Ann Arbor is located in southeastern Michigan, and University of Michigan is here. The main source of energy for Ann Arbor is currently non-renewable energy. However, there is a plan in place called A20, which strives for zero carbon emission by 2030. And this calls for approximately 80% of the energy being solar and home and business electrification of appliances and of vehicles. So majority of the current energy usage in Ann Arbor is non-renewable. The chart shows these sources are natural gas and petroleum. This is because there are two main power plants on U of M campus, which use these energies as their fuel. There are, however, a few renewable energy methods currently in place, such as solar, landfill, and hydroelectric dams. So the current A20 plan requires a program not yet authorized in Michigan called community choice aggregation. However, this would require a law to be passed by the state of Michigan, and DTE Energy, which is the current energy provider for Ann Arbor, is not in agreement with the plan because they believe there's a better method to achieve zero carbon emissions.
So if we look at possible alternative energies, the current hydroelectric power provides 800 megawatt hours per year, while landfill gas provides around 4,000 megawatt hours per year. Wind is more practical than solar for Ann Arbor's plan because Michigan is often doesn't receive much sunlight as many other states. So this would provide a more practical option. And also solar panels would need 32 acres of land to power 1,000 homes. And this would require a lot of purchasing of public land. Hydrogen fuel cells are another option of alternative energy that can be used. This model power plant in Europe represents a possible way that energy could be produced using hydrogen. The hydrogen power plant will produce 12 megawatts of energy at full power in Europe. This hydrogen fuel cells have been proven to be an important a renewable energy as they're used in the US today. Approximately 250 megawatts of electricity are produced with fuel cells in the US. The electricity produced is clean because it's produced by the particles being exposed to the air. Not that much public land would be used if the hydrogen fuel cells were opted as well. The plan is to add hydrogen fuel power plants to the plan to add solar and wind. But since we're using hydrogen fuel cells, less solar and wind will be needed to power Ann Arbor. Pros: more energy efficient, more power extracted. Hydrogen is found everywhere. Hydrogen is not weather dependent like solar or wind, and it can help boost existing renewable systems. Cons: there's a high initial cost because hydrogen is still being developed. In fact, it's $11 to $20 more expensive for every million BTU power than fossil fuels. It's difficult to store due to its low density, and it's hard to transport and store in hard amounts. And there's also safety concerns such as flammability, and sensors are needed to detect leaks. In summary, hydrogen energy as well as solar and wind would provide the primary power to Ann Arbor. Hydrogen would be more efficient and reliable than solar alone. Hydrogen power plants are, in fact, 80% more efficient than gas turbines. There would be less land needed for solar and wind farms, and there might be high upfront costs, but these would be reduced as time goes on as developments are still being made. Here are our references, and if you have any questions, feel free to ask.